Hi guys, Mr. Johnny here, and in this video I'm gonna show you what I did to repair my blown multimeter. Some time ago I was repairing a small CRT television and I on accident I did a dumb thing to be short and essentially sent second anode voltage to the input of this multimeter board, from which you can see on the table. It's a generic sort of a multimeter, but quite nice. Not the cheapest, but provides decent accuracy for me and has a plenty of functions for my usage to repair CRT TVs and some other stuff that I do. Anyway, so that's a board from it, alright? And by accidentally putting in second anode voltage a few kilovolts, that was black and white television, so it's not like 20 kilovolts but more like, and very small, portable, just a few inches worth of screen size, so I guess second anode voltage there is about 5 or so kilovolts, but still quite a huge voltage. And as you can see on the case, the maximum DC voltage is 1 kilovolt, and I won't really trust this thing reading 1 kilovolt. I'll build a divider for it and set it to like 200 volts and read 100 volts when there is 1000 on the input, make a divider for it. Anyway, so by doing that I essentially blown the COB. COB is being chip on board, and that chip I was kind of sure that chip is a chip from Interseal, and that chip is called ICL7106, which is very popular IC for making multimeters. That IC comes in either plastic dip 40 pin package or a TQFP-44 pin package. I found one on eBay. I actually have a video about mailbag in which unpacking the parcel in which I got it, and I'll probably upload it later. So the chip is dead. What can I do? I bought a replacement, and as you can see right now I put a replacement in. You can see this gorgeous soldering job. Just kidding. Anyway, that's essentially what I did to avoid me having excessive hassle soldering this in place. I made a little board, sort of an adapter, just with a place for a TQFP-44 package and lots of pads at a reasonable pitch so I can more or less easily solder to them. And I did just that. And these wires, which you can see from the side view, are nothing else than a clipped off leads from resistors, capacitors and whatnot. You can see the job. You may be able to see there pads, original pads, which were there around the COB itself. I removed the epoxy from the scene. You can see there is no bump, no COB under that. How did I remove it? I took my hot air gun from a station, set it to reasonably high temperature, like 250 degrees centigrade, and essentially heated up the epoxies and just pried it away, chipped it away with a flathead screwdriver. No big drama involved there. In fact, you can see the white sort of a splash where the epoxy would have been. You can see right here. So, but the problem with that, I might blown something besides that, because the thing works, but it has an offset to all readings. So let me demonstrate to you real quick. I'm gonna put the LCD back on. I'm gonna show you what kind of crap it reads on each and every range. Alright, so I put the LCD in place and I put this case nearby in order for you to have a reference what kind of range I'm on. So I'll start with HFE range, and yeah, the chip itself is not fully compatible. The chip that original was there is kind of a knockoff. Not a knockoff, rather a modification, a modified version of ICL7106, which has more functions, like it can sense low battery and display a battery symbol on a screen. This one doesn't have that, but that's no big drama. Anyway, so let me demonstrate you real quick. We are on this setting and you can see nothing connected, absolutely 51. So next we have a 20 kHz range, again reading about 470 Hz, 200 millivolt range, have an offset to 2 volt range, 20 volts. There's here, 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 on AC voltage, on a milliamp scale, huge offset on a temperature. There's nowhere near 40 degrees Celsius, otherwise I wouldn't be wearing sweater. Alright, so next AC amps, you can see your offset, DC, milliamps, picofarads, all that sort of crap. Resistance, resistance has a off reading. When I connect 2.2 ohm resistor, I have a reading of 22 ohms. Actually, let me demonstrate you, because you might not be convinced by what I say. Let me convince you this way. Alright, so this, as you can see, oh, beautiful, is a 470 ohm resistor. I'm gonna put it on a suitable range. So that's 200 ohms, that's 2K. Let's connect it to the proper pins. That's actually not so bad, 500. Not a big of an offset actually, but still. And yeah, so you have an offset. So what can you do? I already found the problem and fixed it, and desoldered that ICs and put back ICs just to make a video and show you guys. So yeah, if you like the video, let me know by hitting like button or leaving a comment. That way I'm gonna see that you like it and I'm gonna make more videos. Yeah, my videos have very small of a feedback, so it's kinda sad. Anyway, so what the problem is? There are a couple of potentiometers in this area. As you can see in a couple of chips. This chip being LM358, this is responsible for driving a piezo buzzer on a continuity mode, and is responsible for auto power off function, which is implemented somewhere. Here you may be able to see auto power off, which is implemented by essentially an NRC time constant and this capacitor right here. So next chip is some logic chip. It's an HEF4070, some logic chip, probably creates a tone for the piezo to buzz on. And this chip being 7555, which is nothing else than a CMOS version of a ever popular 555 timer. This chip being TL062. And so this potentiometer, I don't know what it does, I don't know what this does, but this did have an effect when I tweaked the voltage. Actually, let me show you what kind of weird voltage it reads with these chips in place. So right now, let's click to voltage. That's 200 millivolts or something like that. What it is? Yeah, 200 millivolts, so that's 2 volts, 20 volts. Let's connect this battery. This battery is discharged, and that's 7.56 volts worth of voltage. Let's connect it up. And we see 11.29. Definitely not. So what is responsible for that? By tweaking this potentiometer, I can't get a voltage to go lower, to calibrate it to go lower than 9.5 volts. Yeah, and I know that battery is at 7.56. So what I did is I tried to desolder few chips nearby. This one been desoldered by me quite a bit earlier because I wasn't quite happy with the performance of an auto power off function, so I thought that might be a chip, but that was not a chip. That was a fault of this capacitor. Yeah, to replace this one. So yes, this chip is, I know, is responsible for the buzzer, so it probably shouldn't be connected to the input of the chip ADC in any way. So I tried desoldering the op-amp 062 because that's a JFET input op-amp. They're quite sensitive to static, especially for a high voltage. Desoldered it, the scene remains the same. Then I thought, how about I go and desolder 555 timer. This IC, along with this IC, is responsible for this multimeter to be able to measure frequency. I'll be honest with you, I use this function over the time that I have this multimeter, which is over a year. I used it twice. And just to check the accuracy of my handmade frequency counter. So I do not use it for repairs, like at all. So no big drama if I'm gonna lose it. So what I did is I desoldered this chip and this chip, and it worked fine since then. I was able to tweak this resistor and get this in to read properly. I'm gonna go and desolder these chips right now. I'm gonna show you that it does indeed fixes the problem. So that's how I remove these chips. I take a solder, boring 6337 eutectic solder, and that's how I take off this SO8 ICs. And you can see it from this angle. Oh, that's gonna be a pain for me. But anyway, I'm gonna go and flood these pins with solder. No need for that fancy chip quick stuff. Gonna flood this side as well. Alright. You can see that the IC is flooded with solder. Next I'll go and take my tweezers and like put heat on this side, put heat on the other side, and eventually, well, you'll be able to lift the chip like that. No big drama. Then just go and do like that to take off any blobs that may be formed on the way, and you can see that the pads looks nicely. Now let's take off this 555 timer, which is quite buried in there and quite difficult to take off because I have this stupid connector in the way. But anyway, let's do the same stuff. Let's flood the pins with solder. It takes quite a bit of solder to desolder this kind of crap, but yeah, it's still cheaper than buying a chip quick. And you can see, works like magic. Then you may see blobs formed by Z, but you just can do it like, can clean up the job even without solder wick, just like that. You may have to put some flux on to help you on the way, but you can see quite a clean job. I wouldn't say that that's too shabby. It worth me a couple of seconds. Right, so let's now see the readings. I'm gonna try to show you. Alright, so right now we are on volt scale, same scale, I didn't change it, and same battery. And I'm gonna connect it up. And bummer, we have 7.5758. What I need to do in this case is just to tweak this trim pot, but that's very picky because it's a single turn potentiometer, and you ideally should have like 10 turn trim pot there to make your life much easier, but I don't have any. So the problem was most likely in the 555 chip itself, and I don't really have to remove TL062, but these both chips perform same function here, and they are for frequency counting capability, which I do not use at all. So let me show you now couple of multimeters connected together so you can see for yourself that I'm not fooling you. Alright, so the contraption. You can see this multimeter, MUT, multimeter under test, and this, used as a reference. And you can see for yourself that they are connected in parallel to this multimeter. So if I'm gonna connect the battery, they both should read the same. Alright, I hope you can see them both. You can see the unity as well. Yeah, I think you can. I'm gonna connect the battery. Remember, this battery read under 7.6 volts on my another multimeter. So let's see what these few fellas have to say. Alright, 7.58 and 7.58 on a unity. So that's close enough, I say. I may spend a little bit more time tweaking this to get it closer to this, but that's gonna be hard to do on camera because, as I mentioned, it's quite finicky to tune because of that single turn trim part. But anyway, you can see that the thing is working just fine. Now, next issue that I probably will have to resolve is this thing may go crazy. The buzzer may go buzzing on itself, essentially doing nothing, just sits there on and starts to buzz. So you can see I disconnected it, and I might probably go and clean up the flux from this area, because as I mentioned, this chip is connected to the piezo, so that must have something to do with the piezo. So flux between pins may cause some leakage and make op-amps are sensitive and may cause some unnecessary triggering of the piezo itself. So I'm gonna go and do that, but I ain't gonna show you that. The purpose of this video is to show that you can repair a multimeter which had a chip which is compatible with ICL7106 by replacing the COB with an TQFP-44 on a small adapter board, and the thing will work just fine. You'll be able to measure voltage with it, and you'll be able to measure current with it. And yeah, I did current measurement off camera and it matched just fine, same as voltage. So you have to trust me here, otherwise the video is gonna be very long. If you want more proof, just leave a comment. I'm gonna make a whole entire video showing that this repair multimeter matches all measurement just fine. Resistance, capacitance, temperature, voltage, amperage and stuff like that. Just let me know, I'm gonna probably do a video like that if I have a free time. And I forgot to mention the most necessary part, the pinout. Now, I'm not sure if your multimeter has exactly same pinout, but if you have exactly same multimeter, which is M890G, produced in China, I don't see any brand name except digital multimeter. Yeah. But if you have any problems, let me know in the comments. If I'm gonna have free time, I can help you. Probably. I can't give any guarantees here, but I cannot guarantee that but if I'm gonna have a free time, I will try to help you. So in my case, the particular pinout was like this. Looking from this side, that's what COB looked like. It had 11 pads here, 11 here, and 10 pads on each side, 42 pads in total. So, and the pinout was like this. Starting from upper left, it was D3, E2, F2 and so on, and going like that. And here you can see the pad which says battery low. That's what that is a pad responsible for displaying battery symbol when the battery voltage drops below some threshold. As I mentioned, the original ICL7106 does not have that feature, but you can add it fairly easily by one transistor circuit with two resistors, which is gonna essentially send VCC, 9 volts in this case, to this pad, which is this wire here, when the supply voltage drops below some threshold. And I'm gonna demonstrate that this wire is indeed a battery symbol. So I'm gonna go and hook this to the 9 volt, positive 9 volt battery. And you probably will be able to see a battery symbol. The wire doesn't have any insulation taken off, so that's what makes it difficult. Anyway, it doesn't have any insulation now. Let's touch it and you can see a battery symbol. Now LCD has capacitive features, so if you touch it once and take off, it probably will remain lit if you remain activated some time after that, because it has a capacitance between the thing itself. So that's it. Thanks for watching. See ya.